Good morning, dear friends. Today we'll discuss on chi-square distribution. Chi-square test belongs to a non-parametric category of methods to test a hypothesis. Since we know for testing a hypothesis, there are two categories. One is parametric test and the one is non-parametric test. So chi-square is one of the non-parametric test category wherein we try to prove or disprove the hypothesis with the help of the performance of analysis. The calculated value of a chi-square test statistics is compared with a critical value or a table value to know whether the null hypothesis is true or not. So we have two values. So one is the critical value, which is available from the table, and another value is the value which we calculate. So we compare these both and then we try to prove or disprove the null hypothesis. So the decision to accepting a null hypothesis is based on how close the sample results are to the expected results. So for this, we need to have calculate the table to calculate the chi-square value. So on the base of the formula, so that formula is our chi-square is equal to summation of uh, O minus E whole square divided by E. So there we'll get the chi-square value. And with that, if we compare the chi-square value with the table value, and then we will get we will get the critical value. So when we compare the critical value with the calculated value, so then we can take the decision. So the decision rule uh, is how do we take a decision rule? So that the calculated value of chi-square is compared with the critical value with the significance levels and then degree of freedom. So generally the significance level is 5%, that is 95% of the confidence level. So that is our alpha and that will be 5%. So at 95% confidence level, so we can calculate, we can test. So if calculated value is greater than the critical value, then the null hypothesis is rejected. So which means that the alternate hypothesis is accepted. So then we can conclude that there is a difference between the two sets or the two frequencies, which is very significant. So we can understand the chi-square test with the help of a example. So we'll take an example. So before that, we need to calculate the degrees of freedom. So the degrees of freedom can be taken from the particular table which is shown on the screen. So D represents the degrees of freedom and the probability of exceeding the critical value is our confidence level at 5%, at 1%, and at 10%. So that is what we have in the tables. Now here with an example, we can try to find out the chi-square test whether we can accept or reject the null hypothesis. A company is interested in determining whether an association exists between commuting time of their employees and the level of stress-related problems observed on the job. So here, a study of 116 assembly line workers reveals the following data. So we have the data uh, for three commuting times. So one is under 20 minutes, one is say 20 to 15 minutes, and another is say over 50 minutes. For that, we have stress levels indicated as high, moderate, and low. So totally, we have three number of rows and then three number of columns in this particular data. So these are the totals which are given here. So these are the column totals and these are the rows totals. So the column totals are 44, 19, and 53. And then the row totals are 32, 53, and then 31. So the grand total is 116. So that is the total number of observations. So at significance level of 0.01%, that is 0.01, or you can also say that it is at 1% level of significance, whether there is an evidence that the relationship is significant or not. So that is what we are going to check. So let us perform the calculation and then try to know whether null hypothesis can be accepted or rejected. Yes. So how to do this? So first we'll write the hypothesis statements. The hypothesis statements can be written in this way. So there is no relationship or association exists between two variables. That is, they are independent. And H1 is our alternate hypothesis, which says that there is a relationship which exists that these two variables are related. So let us assume this hypothesis and then we can perform the test. So let us assume the null hypothesis has a stress on the job is independent of the commuting time. So the contingency table here is 3 is to 3, 3 into 3. That is what we have seen here. So three rows and 3 columns. So when we have 3 rows and then 3 columns, so the degrees of freedom can be calculated as row minus 1 into column minus 1. So that is 3 minus 1 into again 3 minus 1, that would be equal to 4. At 4 degrees of freedom, at 0.01 level of confidence, so what will be our table value? So let us see here. So 4 is our, say, the degrees of freedom at 4 degrees of freedom, and at 0.01, so level of confidence, so this will be our critical value. So the critical value will be 13 point, sorry, the table value will be our 13.277. So this will compare with the calculated value and then try to understand whether we can accept or reject the null hypothesis. Yes. So with this we can try this. So let us say, for example, now we need to calculate. So as I said in the formula, so we need to find out the chi-square test. So chi-square test is, so chi-square value can be ascertained by the summation of O minus E whole square divided by E. So O is the observed variables and E is the expected variables or expected frequency. So how we can calculate the expected frequency? The expected frequency, there is a calculation formula here. So the formula says that the row total into column total divided by grand total. So this we have to do for individual observations. The row total into column total divided by grand total. So this is how we calculate the values of E. And then observed variables are already given in the, say, in the problem. So these are all the observed variables. So 9, 5, 18, 17, 8, 28, 18, 6, 7, and then 44, 19, and 53. These are the observed variables. And we need to find out the expected value. So expected value is how to calculate the expected value. Expected value is row total into column total divided by grand total. So this is the row total here multiplied by column total and then divided by grand total. So now we can ascertain here. So this is our, say, row total. So row total is 32 multiplied by, say, column total. Column total is 44 here, then divided by grand total. So grand total is 116. So for the first observation here, so for this observation, that is E11. So E11, so E row 1 and then column 1. So how do we calculate? So row total, that is 32 into column total divided by grand total, that is 32 into 44 divided by 116. So that comes our value for expected value for the first quadrant, that is E11. So similarly, this has to be done for all the things, right? So similarly, it is shown here. So 32 into 44 divided by 116. This is for E11. Similarly, for the E12, E12 is the second quadrant. So for this quadrant, so for this E12, for this, again, we need to do the same thing. So row total into column total divided by grand total. So row total is 32, column total is 19. So 32 into 19 divided by 116. So then we will get the value for E12. So E12 value is 5.24. Similarly, we have to do for all the 9 quadrants, that is all the 9 values of E. Then we can list all these row wise. So 9, 5, and then 18, these are observed variables. And correspondingly, these are the expected values. So 12.14, 5.24, and then we have 14.62. So these are the values. So similarly, we have to do it for all the 3 rows and then all the 3 columns. So we have totally, so 3 into 3, that 9 observations and 9 expected values. So when we have O and then we have E, so then the next step is O minus E, the observed variable minus the expected variable, that is 9 minus 12.14, that is 3.14. Similarly, 5 minus 5.24, so then we'll get the value of 0.24. Similarly, 18 minus 14.62 is 3.38. So this is how we are going to calculate the O minus E, so this column. So O minus E, similarly we have to do for all the 9 observations. Then the next step is O minus E whole square. So O minus E whole square is nothing but the square of this column. So O minus E column, so the square of this column is 3.14 square, and then minus 0.24 square, and then 3.38 square. Similarly, we have to do for all the observations. So the next step is O minus E whole square divided by, again, E. So E is our expected values. So 9.85 divided by 12.14. Similarly, 0.05 divided by 5.24. So then they will get the values of 0.811, 0.09, and then so on and so forth. Then finally, we will need to make a summation of this. So since we have in the formula, this is summation. The summation of O minus E whole square divided by E. So this is the summation. What we have got is 9.836. So 9.836 is our calculated value. So we are comparing this calculated value with the table value what we have got. So we have got the table value as 13.277. So this is the table value, and then we also have the calculated value. Now let us check whether we are testing the hypothesis. Now the critical value of chi-square is 13.3030. This is rounded off at 13 point at confidence level of 0.01 with a degree of freedom of 4. So since the calculated value of chi-square is 9.836, that is the calculated value, which is less than the critical value. So since we can say this is less than the critical value, the null hypothesis is accepted. And hence we conclude that on the job, it is independent of commuting time. So there is no relationship between the independent and dependent variable. So H naught, which is our null hypothesis, this stands as accepted. So now finally we are going to conclude that we are accepting this null hypothesis, and we say that there is no relationship or association which exists between the two variables. That is, both the variables are independent. So this is how we are calculating the chi-square test. Thank you for patient listening.